Assalamu alaikum. My dear student, how are you? Hope you are well. This is Muhammad Ashraful Islam, lecturer, Department of Physics, Milestone College. Today I am here taking an online class. I hope this class will help you the better study at your home. Today I am going to discuss the very important topic, chapter 9, and the topic is refraction of light. Okay, my dear student, let's start our today's class. You can see I take a glass of water and there is a pencil in my hand. If I insert this pencil into the water, then you can see the pencil bends. Why this pencil bends? This is a natural event of light, and this natural event of light is called refraction of light. Now I am going to discuss why the pencil bends. What is the reason behind this? Okay, my dear students, let's begin. My dear student, now I am going to discuss about refraction of light. Refraction of light means if light incident obliquely from one transparent medium to another transparent medium, then it bends from the surface of separation between two medium. This changes of direction of light, it's called refraction. Now I will show you a diagram. In that diagram you can see the light travels from first transparent medium A to the second transparent medium B. I consider here the first transparent medium is air and the second transparent medium is glass. When light travels obliquely from air medium to the glass medium, it bends and goes away from OB direction. But as you know, the light always moves in a straight way. But due to the optical density of this air and the glass, this light bends. And light incident AO direction, and after reflection it bends towards the normal in OB direction, and this is happened due to the refraction of light. Before starting the class, show you a demonstration. In that demonstration I insert this pencil into the water. When light incident from air to the glass, then light bends towards the normal, because here light travels from rarer medium to the denser medium, and due to the optical density of air and the water, the light bends towards the normal, and due to this we see the another position of the pencil inside the water, like this is the another position of the refracted ray, and due to this we can see here another position of the pencil and it looks bends. So this is happened due to the refraction of light. Hope you have understand. Now I will explain you all the terms related to the figure, and it will help you to solve the mathematical problem. In the diagram you can see x prime is the surface of separation between two medium, air and glass. So I write here y is the surface of separation, and n prime is the normal. Here AO is the incident ray. Look this is the incident ray. This direction is downward, so we can say AO is the incident ray and OB is the refracted ray. And the angle between incident ray and normal, it's called angle of incident. So we can write here AON. AON is the angle of incident, which is represent small letter I, and angle between normal and the refracted ray, it's called angle of refraction. BON prime is the angle of refraction, which is represented by R. Sometimes we can see the light bends away from the normal, and sometimes we can see the light bends towards the normal. Now I will show you these two events by drawing the figure.
Light rays travel through space in a straight line at approximately 300,000 kilometers per second. As light passes through a transparent medium such as water or glass, its speed is decreased. For glass, it's reduced to 200,000 kilometers per second, and for water, the speed is 225,000 kilometers per second. If the light enters into a medium perpendicular to the surface, it passes straight through, but at a slower speed. However, if the light beam arrives at the medium surface at an angle, not only will its speed be reduced, but it will bend due to a process called refraction. To better visualize this phenomenon, let's look at this diagram. As a beam of light reaches the surface of a medium, the lower portion enters first and is slowed down. However, the upper portion is still traveling at the speed of light until it arrives at the surface and enters. This speed difference at the top and bottom aspects of the light path causes it to pivot, bending toward what is referred to as the normal. This is an imaginary line drawn perpendicularly to the surface of the material.
My dear student, hope you have enjoyed this video. Now I am going to discuss the topic of this video, which is the change of the direction of refracted ray. And the keyword is when light travels from rarer medium to the denser medium, it bends towards the normal. And when the light travels from denser medium to the rarer medium, it bends away from the normal. So let's explain. In the first figure, you can see light travel from rarer medium to the denser medium. I consider here light travels from air to water. Air is a rarer medium and water is the denser medium, because the density of air is less than the optical density of the water, and velocity of air is more than the velocity of water. When light travels from air medium to water medium obliquely, then its velocity becomes decreased when it passes through the water, and due to this it's bent towards the normal. If you observe this figure, then you can see here AO is the incident ray and OB is the refracted ray, and the angle of incident I is greater than angle of refraction. So if you asked where the refracted ray bend towards the normal, our answer will be when angle of incident is greater than angle of refraction and light travel from rarer medium to denser medium. So we can write the answer: angle of incident will be greater than angle of refraction. Now let's see the second figure. In that second figure, light travels from denser medium to rarer medium. Here glass is denser compared to the water medium. Optical density of glass is more than the optical density of water, and the velocity of light in water medium is more than the velocity of light in glass medium. And when light travels from glass medium to water medium obliquely, then it bends away from the normal. When light travels from glass medium and enters the surface of water medium, as here velocity of light is increased, so it bends away from the normal and goes OB direction. And we can also observe that angle of incident I is smaller than angle of refraction R. So if you asked where the refracted ray bends away from the normal, the answer will be when light travels from denser medium to rarer medium and angle of refraction is greater than angle of incident. So we can write here angle of refraction is greater than angle of incident. Let's explain it again in short. When light travels from rarer medium to denser medium, it bends towards the normal and incident angle I will be greater than angle of refraction R. Similarly, when light travels from denser medium to rarer medium, the refracted ray bends away from the normal. Here, angle of refraction will be greater than angle of incident. Hope you have understand. Now, I would like to discuss laws of refraction of light. There are two laws of the refraction of light. The first law is the incident ray and the normal drawn at the point of incidence from the surface of separation, and the refracted ray lie in the same plane. Now the second law of refraction. And the law is when light travels obliquely from one transparent medium to another transparent medium, then for fixed color of light and for fixed pair of media, the ratio of sine of angle of incident and sine of angle of refraction always remains constant. This constant is called refractive index. This law is given by scientist Snell and it's also called Snell's law. Now I am going to explain the laws of refraction of light. The first law of refraction of light says the incident ray, the normal, which is drawn at the point of incidence from the separation of two medium and the refracted ray lie in the same plane. You can see in that diagram a refraction of light takes place. Here light travels from air medium and falls on the surface of glass medium and it bends towards the normal. Here AO is the incident ray, AOB is the refracted ray and N prime is the normal, and these are lie in the same plane. This is the first law of refraction. Now let's explain the second law of refraction. The second law of refraction is when light travels obliquely from one transparent medium to another transparent medium, then for fixed color of light and for fixed pair of media, the ratio of sine of incident angle and sine of refracted angle remain constant. This constant is called refractive index. In the second law of refraction, there is two conditions. Number one, the experiment must be takes place for the fixed color of light. You know there are 7 colors of light. So for our experiment, we have to take only one color of light. And second condition is the pair of media will remain constant or remain same or remain fixed. Here you can see the pair of media, that is air glass. This pair of media will be remain same. If you observe this diagram clearly, then you can see here I is the incident angle and R is the angle of refraction. And when we increase the angle of incident, the angle of refraction will be changed. So if we consider 3 angle of incident, suppose this angle of incident is I1, I2, I3, and due to these 3 angle of incident, we will get 3 angle of refraction. That means angle of refraction will be changed. Suppose I consider here angle of refraction is R1, R2 and R3. And if according to the second law of refraction, you can write the ratio of sine I and the sine R is constant. So this is for first experiment, and for second incident ray, we can write this formula like that: sine I2 divided by sine R2. That is the ratio of sine R and sine R, which also remain same as before. And finally, for third angle of incident, we will get another angle of refraction, which is R3. So we can write the Snell's law like that: sine I3 divided by sine R3, and this ratio of sine I and sine R also remain constant as before, and this constant is called refractive index, which symbol is eta. So the formula of refractive index will be eta equals to sine I divided by sine R, and this is the formula of refractive index. If you observe this formula, then you can see here refractive index depends on angle of incident I and angle of refraction R. Relative refractive index. Relative refractive index means the refractive index of a transparent homogeneous medium compared to the another transparent homogeneous medium. It's called relative refractive index. Let's see the relative refractive index through a ray diagram. Look at the diagram. In the diagram, you can see here light travels from A medium and falls on the surface of B medium, and after refraction it bends towards the normal. So in this refraction of light, the refractive index of B medium, the respect to the refractive index of A medium is, and it can be right here, will be right in this way, that is refractive index of B, and the respective medium you have to write in the left side of this index, the refractive index eta. This is the process of writing the refractive index of B medium respect to medium A. So it's refractive index of medium B with respect to medium A. This is the way to write the relative refractive index. Now, as you know, the formula of refractive index is sin I by sin R. This is the formula of refractive index. Here light travels from A medium to B medium, so the relative refractive index will be A eta B, that is refractive index of B medium respect to the medium A, and its formula will be sin I by sin R. I is the angle of incident, R is the angle of refraction. Now if we change the direction, here, suppose light travels from here medium B to medium A. If light travels from medium B to medium A, then this incident angle will be R and refracted angle will be I. So in this situation you can write the refractive index of A, and the respective refractive index will be B. So this is the refractive index, and the formula will be sin R divided by sin I, and this refractive index of A respect to B will be reversed to the refractive index of B respect to A. So in mathematical term we can write 1 by sin I divided by sin R. Now if we put the value of sin I by sin R as refractive index of B respect to A, then we can write B eta A equals to 1 by A eta B. That is, the refractive index of A respect to the refractive index of B is reversed to the refractive index of B respect to the refractive index of A. Now absolute refractive index. An absolute refractive index means when light travels from vacuum medium to another transparent medium, then for fixed color of light and for fixed pair of media, the ratio of sine of angle of incident and the sine of angle of refraction is constant, and this constant is called absolute refractive index. In another word, we can say the refractive index of any transparent homogeneous medium with respect to the vacuum medium or zero medium, it's called absolute refractive index. That means if light travels, suppose medium A to medium B, and if we consider this medium A is vacuum, then the refractive index of medium B with respect to the vacuum, it's called absolute refractive index. And absolute refractive index can be write in this way. Suppose refractive index of medium A with respect to the vacuum, it can be write in this way, O eta A or only eta A. So the absolute refractive index of medium A can be light eta A. What does it mean? It means the refractive index of medium A with respect to vacuum is called absolute refractive index of medium A. Now, refractive index of medium B with respect to vacuum. This is also called absolute refractive index of medium B, and it can be write A eta B or only eta B. So, the absolute refractive index in medium B will be eta B. Now, you know the refractive index of medium B with respect to medium A, it can be write A eta B, and the formula will be the absolute refractive index of medium A and the absolute refractive index of medium B. This is the formula, and let's consider this is the equation number 1. And as you know, the refractive index is the ratio of sin I and the sin R. So according to the second law of refraction, we can write the refractive index of B with respect to A is A eta B equals to sin I divided by sin R. So this is the another equation. Let's consider this is equation number 2. Now if we compare the equation number 1 and equation number 2, then we will get another equation. So we can write here comparing equation 1 and 2. We can write eta A divided by eta B equals to sin I divided by sin R. Now after cross multiplication this expression, we will get the formula is eta A into sin R equals to eta B into sin I. Eta B into sin I. So this is the formula to calculate the absolute refractive index in any medium. Here AB is the absolute refractive index of medium A, and eta B is the absolute refractive index of medium B. I is the angle of incident and R is the angle of refraction. That's all about the absolute refractive index. Hope you have understand. Before starting the mathematical problem, let's have a look all the formula related to our today's topic that I have discussed in my today's class. The first formula is A eta B equals to sin I divided by sin R. Here I is the angle of incident and R is the angle of refraction, and A eta B is the refractive index of B with respect to the medium A. The second formula is B eta A, which is reversed to the A eta B, that is 1 by A eta B. Here B eta A is the refractive index of A medium with respect to the medium B. And the last formula, which is eta A into sin R equals to eta B into sin I. Here eta A is the refractive index of medium A and eta B is the refractive index of medium B. And this is the formula. Let's have a look a mathematical problem. Let's solve a mathematical problem. The problem is when light refracts from air to water, then the angle of incident is 30 degree and the angle of refraction is 19 degree. Question is find the refractive index of water with respect to air. So let's solve this question. First, we have to write the given information. Let's see the given information here. that is angle of incident is given here. Angle of incident. Angle of incident is I, and whose value is given here 30 degree, and angle of refraction is also given here. So we can write here angle of refraction. Angle of refraction is represented by R, and whose value given 19 degree, and we have to calculate the refractive index of water respect to air. So refractive index of water respect to air, which is represented by A eta W equals to what? Now you know the formula to calculate the refractive index of water respect to air is A eta W equals to sin I divided by sin R. Now if we put the value of I and R, then you can write refractive index water respect to air is sin 30 degree divided by sin 19 degree, and after calculation that expression we will get the refractive index of water respect to air is 1.538, and this is the answer of the question. And there is no unit of refractive index because it's the ratio of same quantity. Your today's homework, knowledge based questions. First, refraction of light. Second, refractive index. Third, what is absolute refractive index? And at last, states the second law of refraction of light. And complete this homework and submit to your respective subject teacher. Okay, my dear student, that's all for today. Thank you for your patient hearing. Stay safe, stay home.